Okay, so in order to complete the lizard array problem, you do have to be able to generate random numbers. Unfortunately, we don't have one as nice as Greenfoot available to us on the AP Computer Science exam. We have to use math.random. So let's take a little bit of a chance to look at what math.random is. It's a static method in the math class. All methods in the math class are static. What it does is it returns a random number of type double between 0 and 1. So every time I call it, it'll be something different. And the number cannot be 1. It can be 0. So what I usually say is that you want to think of math.random like an inequality. That if x is the value that math.random returns, it's like this. Okay? So let's say I want a random number from 0 up to 30. Well, then I just have to multiply all three sides of this triangular inequality by 30. That's what you would do. I'm allowed to multiply all three sides. And so now what you can see is 30 times x is between 0 and 30, not inclusive. So if I want a random number between 0 and 30, I just simply say 30 times math.random. This number will not be 30, but it could be 0, right? Because it's 0 up to, but will not include it. Now, that's really helpful because if I have an array, let's say like I have an int array r equals new int, and I'll use an initializer list here. Okay, of course it is. Sorry, I guess I already made one earlier. We'll call it array. Let's see if I have that. All right. So I can simply say the length of this array times math.random. And that is going to be a number between 0 and not including the length of the array. And remember the index here, this is 0, 1, 2, 3, 4, 5, 6, 7, 8. The length is 9, but I'll never get that 9. And that's good because if I had 9, 9's out of bounds. But remember, if I want to use this to access a certain element in the array, a random element, I need to cast it as an int. So, and I'll show that separately. Watch what happens if I do this. I'm going to cast as an int there. Nothing works because all I'm doing is casting array length as an int. Because int casting occurs before multiplication. So you might think, okay, well, I'll do this. I'll cast math.random as an int, and then I'll multiply by length. Well, the problem there is now I'm going to get 0 every time because remember, this is a number between 0 and 1, and you cast it as an int. Casting as an int removes the decimals. You know, if I have the number 0 point that, as soon as I cast it as an int, it just removes the decimal. Even if it's a really high number, it just removes all the decimals. So what we need to do is we need to cast as an int, which means you put int inside parentheses, and it doesn't matter the order here. I usually do length first. Now that will be a random number, a random integer between 0 up to and not including the length of the array. So that is exactly what I need if I want a random value from the array. This will return for me a value at a randomly chosen index. And you'll remember my array had these numbers in it. Okay? So that's how I would do that. Now, let's say I want a random number between, say, 75 and 80. How would I do that? Well, to do a random number between 75 and 80, I need to think, well, 75 and 80 Let's go back to here. And we'll say from 75 inclusive up to 80 not inclusive. Well, that's 5 numbers. So I'm going to multiply everything by 5. Right? The difference between 75 and 80 is 5. So I put that. Then I simply add 75 to each one of these numbers. And I always go back to my little inequality here to see how can I construct this rule to make this work. So now I can see that this is the expression I need. Remember, x is math.random. So if I want a number between 75 and 80, I'll just say 5 times math.random plus 75. This will be a number between 75 and 80. If you want it to be an int between 75 and 80, cast it as an int, but you have to put it in parentheses like this. All right, last thing I want to go over is how can I get a number, a Boolean, to be true a certain percentage of times. Well, if I want, say I want the value B to be true 37% of the time. Well, 37% is 0.37, right? Well, math.random returns a random number that is less than 0.37 37% of the time. So that time it's true. This will be true 37% of the time because this number is a number between 0 and 1, evenly distributed. All right. Well, that's it for math.random.